Have you ever asked yourself how these technologies were made? What kind of integrations might have been involved in creating them?
People often say that mathematics is everywhere.
Do you think this is 100% true?
Do you think that mathematics plays a crucial role in the emergence of technology?
If you didn't know the answer to that,
Then let's unravel it together.
Mathematics has a truly universal applications because it provides fundamental language and tools needed to understand and solve problems in almost every domain of human activities.
From everyday tasks like budgeting and cooking to complex areas such as science, engineering, finance, and technology, math helps us model natural phenomena, develop new technologies, optimize processes, and make informed decisions both in our personal and professional lives.
now the question is, how was mathematics integrated into the creation and development of technologies?
In electronics and computers, logic, algebra, and number theory are everywhere. From writing algorithms to storing data in binary form, math makes computers work reliably. Even communications and networks rely on math. Probability and statistics optimize how data travels, reduce errors, and make sure your messages arrive safely. Now, let us know few persons behind the creation of the kind of technologies we enjoyed using today. He developed digital security and cryptography, encryption that protect digital communications, engineering and telecommunications, signal processing, design of mobile phones and wireless communication systems, medical imaging and data science, compressed sensing and implication for faster MRIs, and predictive modeling, weather forecasting, and financial market prediction. But we will going to focus on the digital security and cryptography, in where he developed secure encryption methods that protect digital communications and online banking through his work in number theory, particularly concerning prime numbers. Cryptography relies heavily on number theory, especially the behavior of large prime numbers. Encryption systems like RSA depend on the fact that prime numbers are extremely difficult for computers to break apart. Dow studies the pattern, structures, and unpredictability of these primes through his work in number theory and additive combinatorics. His finding helped experts understand how strong current encryption methods truly are and how to design even more secure systems. While he does not create encryption software, his mathematical research provides the solid foundation that keeps digital communication safe from hackers. Cedric Villani did not invent a machine or a device, but he developed powerful mathematical ideas that modern technology relies on. One of his major contributions is to the Boltzmann equation, which describes how huge numbers of tiny particles, like gas molecules, move, spread out, and collide with each other over time. This equation is essential for creating accurate computer simulations of gases and fluids. Engineers and scientists use these simulations when designing airplanes and rockets to study how air flows around wings and bodies, reduce drag, and improve fuel efficiency. The same mathematics also helps in understanding how electrons move inside materials, which is important in designing computer chips and electronic devices that are faster and more energy efficient. Villani also made major advances in optimal transport, a branch of mathematics that studies the most efficient way to move things from one arrangement to another, whether those things are physical objects, energy, or even data.
This theory has surprisingly wide applications. In artificial intelligence and machine learning, optimal transport is used to compare and transform data distributions, improving how AI models learn patterns. In image editing and processing, it helps with tasks like smoothly morphing one image into another or adjusting colors in a realistic way. In the real world, the same ideas are used for planning delivery routes, organizing resources, and optimizing logistics so that goods can be transported more efficiently and at lower cost.
Shafi Goldwasser used advanced mathematics, particularly number theory, probability, complexity theory, and algebra, to build the foundations of secure communication systems. One of her biggest ideas is called zero-knowledge proofs, which lets someone prove they know a password or secret without actually showing it, and probabilistic encryption, which uses number patterns to make messages look different every time they are encrypted. But we will focus on her creation in probabilistic encryption. Probabilistic encryption works by adding randomness to the encryption process so that the same message never produces the same encrypted output. Before a message is encrypted, the system chooses a random number and mixes it with the message using mathematical rules from number theory, such as modular arithmetic and quadratic residues. This randomness means that even if someone encrypts the same message twice with the same key, the ciphertext will look completely different each time. Because there are no repeating patterns, hackers cannot compare encrypted messages or guess their meaning. Only the person with a private key can remove the randomness during decryption and recover the original correct message. This mathematical technique, developed by Shafi Goldwasser, makes modern digital communication far more secure. Thanks to her work, technologies like online banking, secure messaging, e-commerce, and blockchain can stay safe from attacks. Her math helps make the internet a more private and secure place for everyone.
Cedric Villani, Terence Dow, and Shafi Goldwasser are the three influential mathematicians whose ideas quietly power many of the technologies we rely on today, even though they never built physical machines or devices themselves. Instead, they created the mathematical foundations that modern engineers, computer scientists, and technology developers use.
Their work strengthens major fields such as artificial intelligence, digital security, engineering, and data processing by providing the theories and methods that make these technologies accurate, efficient, and secure. Villani's breakthrough helps simulate real-world physical systems.
Dow's research improves how computers reconstruct signals and protect information. And Goldwasser's innovations ensures the privacy and safety of digital communication.
Together, their contributions show how mathematics shape the hidden structure behind today's technological process. And that's all. Bye!